Okay, we are working on solving systems using Cramer's rule. And it's just another way of doing systems with matrix. And a lot of it has to do with using the determinant. So the way I find my x value is I take the dx over d. And let me explain what that is. D is going to be your coefficient matrix. My coefficient matrix is 2, 5, 3, and 4. Okay, that's my coefficient matrix. But on the top, I'm going to do the, I'm going to substitute, if I'm working on x, I substitute my constant matrix in for my x values. So instead of 2, 3, this is going to give me 9, 10, but the y's stay the same. Okay, so let me repeat that. The bottom, this is your coefficient matrix. The top is I'm subbing the constants for my x values. Okay. Then what I do is I do my determinants. And remember, determinants, I take AD minus BC. So for this first one, AD is 9 times 4, so that's 36, minus my AC, which is 10 times 5, which is 50. And 36 minus 50 is a negative 14. And then I do the same thing on the bottom. My AD is 8 minus my BC, which is 15. And 8 minus 15 is negative 7. Negative 14 divided by 7 is 2. So that's my x value is 2. I'm going to do the same concept for my y value. Okay, remember the bottom one is going to be your coefficient matrix, 2, 5, 3, and 4. For my top one, this time I'm going to keep my x values for my coefficient matrix, and I'm going to substitute my constant in for my y values. So this is 9 and this is 10. Okay, AD minus BC, A times D is 20, B times C is 27. On the bottom, 2 times 4 is 8, minus 3 times 5, which is 15. 20 minus 27 is a negative 7. 8 minus 15 is a negative 7. So that's a 1. So my solution is 2, 1. Okay, if I plug those in, 2 times 2 is 4, plus 5 times 1 plus 5 is 9. 3 times 2 is 6, plus 4 is 10. So they work. Okay, so just do that quick check to make sure you got them right. So let's try this again. It's just, again, this is just another way of doing it. Okay, I'm going to start with my x. It's going to be dx over d. Okay, the bottom is my coefficient matrix, so I have 2, negative 3, 5, and 4. The top, since I'm looking for x, I'm going to substitute my constant in for x, and I'm going to leave my constants for y, or my coefficients for y, and then I'm going to do my determinant, which is AD minus BC. So A times D is 28, B times C is 5. Then on the bottom, 2 times 4 is 8, negative 3 times, minus a negative 3 times 5, so that's plus 15. Is that a negative 3 on the bottom? Yeah, so it's plus 15. 28 minus 5 is 23, 8 plus 15 is 23, so my x is 1. Okay, I'm going to do the same thing here with my y. Coefficient matrix stays the same, 2, negative 3, 5, and 4. This time I'm going to keep my coefficients for x, but I'm going to replace my y coefficients with my constants. And then I'm going to do AD minus BC. 2 times 1 is 2. Negative 3 times 7 is negative 21. So 2 minus the negative 21 becomes 2 plus 21. On the bottom, I have 2 times 4 is 8, minus a negative 15. So that's plus 15. So I have 23 over 23, which also equals 1. So my solution is 1, 1. 2 plus 5 is 7, negative 3 plus 4 is 1. It works. Okay, again, just another way of doing it. Okay, we'll do one more. Number 3. Okay, for my x value, I put my coefficient matrix on the bottom, negative 1, 5, 3, and negative 2. On the top, I'm going to substitute my constants in for my x's, but I'm going to keep my y's. And then we're going to multiply a times d, 12 times negative 2 is negative 24. That's negative 40, so I'm subtracting a negative 40, so that's adding 40. Negative 1 times negative 2 is 2 minus 15. Negative 24 and 40 is 16. 2 minus 15 is a negative 13. And this is one where we don't have constants, and that's okay. So then on this one, I put my coefficient matrix goes on the bottom, so it's negative 1, 3, 5, and negative 2. This time I'm going to keep my x values, and I'm substituting in my constants for my y values. So negative 1 times negative 8 is a positive 8, minus 3 times 12 is 36. On the bottom, I have 2 minus 15 again. 8 minus 36 is a negative 28. 2 minus 15 is negative 13. So I have a positive 28 over 13. So my answer is negative 16 over 13, comma, 28 over 13. And that's solving using Cramer's rule.